Alright, so, man, that's odd. Let me just look at something. The background always looks green to me, but I'm pretty sure that the background was, yeah, it's just light gray. It's just that the green text, something like that, gives it an illusion of greenness, but it's not actually green at all. Huh. I like it. It's cool. Like, man, it looks so green to me. That's weird. Hmm. I wonder if it's like my screen. Let me. Also, that doesn't show up on. No, it doesn't. Alright, cool. Let's see. Let me see if I can. Hmm. I don't know. It's weird. It looks less green on that monitor. Well, it looks less green in OBS. It looks just as green while looking at it on the monitor. So I guess it's just an illusion situation. Okay. Anyway, so the state of the docs right now, it's pretty much exactly where it was last time. The only difference is the few new functions that I've implemented are now available here. So there's show mouse cursor, set active view, and view set split proportion. Those are the and view setting, view set setting. Those are all new, but other than that, it's all exactly the same. The system for generating it's the same as what you saw if you saw the last documentation generator stream. So today, what I want to tackle is that I've got a bunch of enums with different flags and not I don't know what to call it. There's like enums and then there's like flag enums, which are two separate sort of things. But both of those I want to generate docs for today, if possible. But the trick is that right now those are all just dropped in haphazardly in custom.h. So what I want to do is first I want to pull that out into a separate header that I can, sort of separate out the types that explicitly are, used for generating stuff. So something like that. And I would like to include that right here. Or, yeah, I guess right there for now. And then, let's see, I'm not going to put the strings through the documentation, but here we go. Modifiers, yes. So let's bring those in there. And in the past I was doing all kinds of fanciness with how I was, putting the enum here and there and whatever. I just want to, by the way, make sure that this thing is building all the way through. Hey, Chrono Dragon, what do you mean by bit field? Oh, you're talking about the thing I was saying about enums that have flags versus just standard enums? Because like this over here is just standard enums. I'm giving an index to each key control value. Actually, where do I use that? I forget where that shows up. Somewhere else I have modifier. Oh yeah, that's for this modifiers array here. So I'll take all of those. Mouse state, I'll take that. Range, I'll take that. I don't want these functions here, I don't think. File info, file list, I'll take those. I'm going to cut out all the comments for now. Chrono Dragon, so the plan, and this isn't like true, like inline is C++ specific and stuff, but the plan at one point was that custom.h would actually be C compatible and that all the helpers would be C++, but if you wanted to drop down to C, all you would have to do is not use the C++ helpers and make your make a C helper instead, but like I haven't totally stuck to that, so it's not like totally accurate, but I'm still doing it at least for now. I might end up cutting it out completely at this point because I'm about to add I'm about to try to generate docs from the stuff I'm putting in this file here, and so having the extra stuff to parse, I don't know, it still shouldn't hurt, because I'm just gonna add like my sort of standard blah, and then I'm gonna API export each of these things. So I just need to keep looking until I find, like, you know, read these and that'll tell me what type I'm looking at. But not doing that quite yet. So I'm gonna hold off until I have a chance to think about it. Now, one thing I want to do is, it's not clear to me whether I actually want to define the enums directly, because an idea I've had recently is I don't want strongly typed enums at all. And what I would rather have is what I'm doing here, where I type def the name of the enum to a uint64 or to whatever type I want, and then I use an anonymous enum here, or I could like just take a version of the name with like an underscore or something, right, to hide it. So it doesn't conflict with that name. I'm going to leave hooks there for now because I'm not quite done messing with them anyway. And I'm not sure what I'm going to do about them. I mean, documenting the hooks will definitely be important, but yeah. It's just some unanswered questions about them, since I'm going to phase them out eventually anyway. There's some unanswered questions about how I want to, how much I want to put into that, and how I'm going to make them continue to work in the future versions. So what I'm thinking here is maybe I want to auto-generate this file that I'm writing by hand right now. And the reason I'm thinking that is, well, I don't really like having to, like, I could imagine setting up a system where I don't have to manually manage the flag versions of enums by doing the 1248 thing, where that would just be auto-generated. And I could imagine that would also make it really easy to do the thing I want to do, where I don't actually have enums that I name directly. I just have them all be sort of anonymous, or I mask their name and then I just type def to the actual name, so that they're a little different. But for now, I'm going to go with this, and then maybe the next step will be to think about how to auto-generate this file from a sort of spec file or something. I know in the case of the implementation, it ended up being that I just wanted it all in one place, and so the implementation ended up being where I would read out the names of things. So that's why I have API export there. And I'm imagining it might be the same here, but that doesn't necessarily mean that the one file I write has to be the one file that gets like built in with the actual definitions of things. I'm just not quite sure what I want to do. The advantage to making the definitions of things actually the thing you parse from and then include that into the code too is that you get like two checks on its correctness, the compiler and your parser. So like you can easily, just like you don't risk having this sort of split of information that you end up having to manage a little bit. I don't know, not sure. Okay, so let me think. Oh, this isn't quite ready yet. While I'm sitting here doing rote business, I'm thinking I definitely want to try the spec file first. So that means this whole thing here, what I actually want to do is throw that out and go like spec 4coder types.h. Right? And then what I do is this doesn't look like that at all. It'll just be auto-generated from the thing I've got over here. And then the thing I've got over here will not actually be included in anything. It's just going to go through my parser, and then I'm going to spit it out into the 4coder types header afterwards. Okay, so if that's the plan, then Hey, Fucon. So I want to figure out what kind of markup I want to do, and right now the first thing I'm missing, where are my modifiers? Like the modifier flags. I don't understand. Let's go back to custom H. I feel like I'm gonna miss a lot of stuff from these things. So let's like, what's in key codes, for instance? Oops. Oh wait, there they are. Hey, Chrono Dragon, so that's an interesting question. Originally, that's exactly what I was doing. That's why they look kind of like macros. Was I was doing doc, etc. It turned out I didn't like that because there was a few issues. The thing that turns out to be the biggest issue is actually just doing one comment is easier because the Lexer pulls this comment out as one big token, whereas if I don't, I then have to look across multiple tokens and keep going until I find an open brace, and then I have to like make sure I'm keeping track. Like, was this open brace actually an open brace, or was it like during one of the what is it like the actual beginning of the function, or is it something else? Blah blah blah. If I just make it the comment and say that there's the function signature here, and then one big comment, and then the function definition, then there's one token to pull out that has all the doc strings in it. Then I can parse the doc string inside there. I mean, it's not that hard with Elixir to just say if I wanted to, like, take the string from here to here and treat that as one file again, where last time it was a comment, but now I've taken out the part that makes it a comment, right? I just ignore the comment part, parse that, and it'll give me tokens for that. So that was an option, but I ended up not even doing that because the other issue is apostrophes, right? If I type anything with an apostrophe like this, that will mess up the lexing entirely. So yeah, so now that I've switched to the comment thing, it would make sense to switch to a different syntax, which I've thought about doing. I just, it already exists and I've got the thing written that reads this. I don't, unless I have a really good idea for the syntax, I'm not too worried about switching to something else. But yeah, it turned out the comment was pretty important so that I could get the apostrophe S. Now if I had something that didn't need like delimiters or something, I'm not sure what I would do. I mean, you need something, some kind of light markup system. I don't know. This was not too hard to get working, so yeah, that's a good idea. That's a good idea. Um, okay, so anyway, what I want to do now is I want to come up with how I'm going to document all these things. And really, there's different types of things here. I've got just a straight type def. Yeah, and this is where I don't want the other type def to be seen as a straight type def. Okay, so this is the spec file. What I'm going to do in the spec file is we're going to say that this isn't real code. So what I'm going to do is all of the work I did to put in these extra things here are going to go out. Oops. And blah blah blah. You'll just be called command ID for now, like so. Okay. Next, what I want to do is say, let's take all of the enum type things and put them in one spot so that I can think about them together. Enum. Okay, so it looks like I've got all the structs up top and all the enums down below. And now, basically what I'm going to have is there's just a few basic types of things. There's going to be the standard type def, which will go original new, and then, or I'll just do O and N, type def ON, and so I can do something like type def unsigned char to code. Then I want how am I going to, what would I do to put documentation on this? I could just say that there's always a comment right after the semicolon. Right, each of these things ends with a semicolon, although these have semicolons in the middle. So maybe the way I want to do the docs is the doc string goes like right here. Right after the keyword. How would that look down here? Because then here I could just go doc the type for any key press event for describing key press events. And then this would look something like struct that thing, and then this. And of course, this doesn't need to be quite so crazy. We can experiment with doing a completely different syntax if we want. Maybe, okay, if I put it right before the thing, that seems cool. Alright, so I'm going to go with something like this. I'm going to put the main description right above, and then that means for each of these things what I can do is go like, alright, so we have, and I want this to be more like API type def, define API struct. API struct is just struct. And then I put in a doc comment here. And then what I want to be able to do is these are parameters. Now, do I list each I don't see any reason. Honestly, I don't even really need to... well, it does come down to whether or not I want to export that struct or not. Since this is a spec file and not a real file, and I'm doing fancy shit, I feel like I'm exporting everything. So I'm going to do a quick change of plans. Type def there, and no macros at all. Right? And then what I'll do is, there I go, there's doc, add doc, right, and I'll just put the doc above each parameter like so, or each field, and then this will auto-generate code where it strips out the comments basically, or something like this. Maybe. What about this? Do I want to separate out L, R, L, R, L, R everywhere, and X, Y, and min, max? Or do I want to be able to set the parameter names in what I'm doing. So maybe I say I've got like a param, or not param, those are fields. Field. And then what I can do is say, or what I could do is, that duplicates the names, but it also means that it forces me to check this whenever I update the fields. I'm just going to go with this one. I think that this will be the most straightforward way to do it. You know, I can't do that. I've really got to do it this way. Oops. And the reason I want to do it that way is because once I get the token, I want to be able to chop these things off there. If I do, like, if I want a long comment and I do lines like this, then I have to like manually remove these slashes that are in the middle. Like it'll go doc to mark the beginning. Here's a lot of stuff I have to say. Here's even more stuff. I now have to like manually delete these out, which is not what I want to do. Oops. Doot. 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 Da 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 da. Alright, so that's how all those will work. Is there any reason why these wouldn't be the same, I wonder? Yeah, I think from here, these would all be the same. Like, at least from what I have to write in the spec file, it would all be the same. Now, do I want to specify the difference between flag enums and normal enums? Do I want to have like a flag enum type def in here? Actually, I do want to change the syntax up a bit here. Ow. And the reason is I want to add like okay, so I want like define enum type name. This just comes out as enum name. Whoops, let's do that this way. Enum just enum name. Yeah, so this would be like a flag enum key control flag. Okay, cool. So this would be enum uint 64t. Oops. Alright. Let's see, what is this one? This is an enum. It's 32t. This is an enum. It's 32t. Buffer setting ID. Oh, and I need to add in the doc strings. Int 32t. Doc. Let's see, enum int 32t. Doc. Enum flag enum. Uh-oh. Hexchat just crashed. Do I still have OBS? Yeah, OBS is still working. Alright, let's see. Boop. Boop-a-doo. Do. Alright. Flaginum. Doop-a-doo. Flaginum. Doop-a-doop-a-doop-a-doo. Flaginum. Doop-a-doop-a-doop-a-doo. Flaginum. Doop-a-doop-a-doop-a-doo. Flaginum. Doop-a-doop-a-doo. Flaginum. Doop-a-doo. Flagging 'em. Doop-a-doop-a-doo. Doop-a-doop-a-doo. Doopa. Doop-a-doop-a-doo. These don't work. These don't work. Enum int 32t. Doop-a-doop-a-doo. Okay. So now I've gone and added doc strings to everything that just says to do everywhere. It's got a new format that I'm going to try with, and this doesn't have any fancy. What I could do now, in theory, is start just putting HTML right into the strings, actually. Not sure if that's what I want to do. Doesn't seem great, because I thought about also compiling or like outputting LaTeX version, since I can make the formatting nicer there without like hemorrhaging my skull. And Hex Chat is back to working. I can see some chat stuff happening. That's good. Alright, so now what do I want to do? Well, I've gone and replaced everything with this system, and I want to first, before I do, I said I would do doc generation today, but actually first I just need to parse this whole thing, which is not too hard. You'll get to see me work on that. Let me make sure this still builds. Ooh, what's going on here? Right. Okay. Doop-a-doo. Temporarily, I'll just drop this in here so everything will keep working. Great. So now, yeah, let's get to the parser part. So metagen CPP. Yeah, it's going to have to be a part of custom headers, since that's where I'm doing all this other custom generation stuff. So now, this is not really correct. Code data. I'll just put this here at the top so that it's easy to find. Code data, or we'll call this like types code equals file dump. And now I want to dump, and I wish I could get rid of the mouse. In the newest version that I haven't actually upgraded to yet, but what I did today is I made it so you can hit F2 to suppress the mouse, and then it hides the mouse, and mouse input no longer is visible. Okay, so I want to file dump the spec for 4coder types. And then what I want is, I want a parse. Wait, what does the parse struct have in it? just tokens. Okay, so I'm gonna skip that and just go with tokens equals. This is kind of fun using the there it is. Using the Lexer to do stuff is always fun. Stuff other than like the built-in 4coder stuff. Because then in the 4coder version I turn off all of the malloc features. Any feature that relies on malloc gets disabled, and so then you have to like manually give it memory and manage it a little bit, and it's trickier. But here I'm just sort of doing utility uses, and so I just open up the full can of worms and just malloc whenever I want. So now I can just do like 2 function calls to lex the whole file. I do have this fucking shit right here that I wrote because I was super dumb, where I have to turn it into a CPP file, which is just a different struct that is exactly equivalent to a string, basically, for no reason. And you can see I want to get rid of that. But that's okay. So then, I blah blah blah, I blah blah blah. This is going to be the types tokens. Types tokens equals make that stack. Yeah. Okay, so let's just put you right here, actually, and then CPP lex file lexes the whole thing. If it runs out of memory, it mallocs more. It's great. So that means I now have the whole thing lexed, all of the types. But I still need to do some other stuff, right? So I've got the tokens from this file in this token stack. Next, what I want to do is I want to loop over those tokens and read stuff out, and I need a data format to write that crap into. So let me just take a quick browse here. I've got basically structs. Structs and unions are one thing. I'm going to treat them as one type of thing. Enums and flag enums. Those are the 3 types of things that I've got. Oh, and I have a type def. Right, so I have type defs. I have 4 types. I have type defs, structs and unions, enums, and flags. And I have some variable number of each of those. Each of those has, other than a type def, which is just an identifier and then a bunch of other nonsense to the right, to the left of that identifier. But these all get broken down more. So each of those has a top-level docstring and then a bunch of members, and then each of those members has a docstring and a name, and depending on what thing you're in, it also might have a type. And if I'm also thinking carefully, I kind of want to represent this structure so that when I spit out the matching code, I keep all the struct sort of nesting correct. So I actually kind of am going to parse structs and unions today for one thing. Not totally, I'm not going to error check it or anything, but I'm going to sort of make a build out the tree entirely. So there's a lot of different things in there. So I'm going to call this the type up there I have a function set. I'm going to just go struct set, and then enums. I also need type def set, flag set, and an enum set. Okay. And those will look like this. Where's my function set? There it is. Don't ask me why it's in like C style. It doesn't. I don't know why. I just do that randomly sometimes. But right now it's bugging me, so it's going away. Struct typedef set. In each typedef, I need an array of the full, full. Well, I need basically the type and the name and the doc string for each of those. I need the for each struct, I need this will need to be a little more complicated. So this will be like a bunch of struct members. I'll call these the struct, and a struct member will basically have a name, type, yeah, and then it'll have a first child and a next sibling. So I'll have a bunch of those to make a struct set. Okay, and let's see, so there's a struct set. I need what else did I say I need? A flag set and an enum set. These might work out to be fairly straightforward. Alright, so for each of these I need an array of names. For the enum set I need an array of types, and then under each of those I need the main. Oh, that reminds me, this here needs a doc string. And then for each of these I need a main doc string, as well as, well, no, I need doc strings for each of those. And then each of them has an arbitrary number of members. Each of the enums and flag enums. So enum member. Each one of these has a next, a name, and a doc string. And we have a bunch of enum members. First member. Yeah. Okay, so the next thing I want to do is I'm going to go ahead and quickly introduce the partition code to this system. Okay, yeah, cool. And now, okay, now what I want to do is say, cool. All right. Right, so now what I basically need to do is write the loop that parses this entire thing, which is not that crazy. So I'm going to take the types tokens, which has a count. I'm going to take the first, well, I'm going to take the tokens there because I'm imagining I'm probably just going to want to be able to get to those tokens all the time. And then I'll take the first token and we'll do a loop across them all. Oh, I don't have any water. That's a mistake. I'll have to go get some water in a moment. But let's see, how far have I gotten so far? I am looping across the tokens. Yeah, so what I want to do now is basically during the loop, what am I looking for? If I see the word typedef, struct, union, enum in caps, or flag enum in caps, I want to stop. So those are the things I'm looking for first of all. If the token type equals CVP token keyword, keyword, what type of keyword is it that I'm thinking of here? Key type declaration, yes. So if I see key type declaration, I want to stop, potentially, right? And what I want to do is say, alright, get the lexeme for this token, then what I want to do is say if string set match, if the lexeme matches anything in the set, now let me switch over to string real quick and look at how string set match is set up. Okay, so I need a string set, which would be um, uh, actually what I'll do is I'll say, look, if I see a token declaration, or if I see an identifier I want to stop, if I see one of the type spec keys, type spec keys, okay, there's the string I want to match, and the match index. So this would be match index, which I'll throw in right here. Now, for that to work, I need to introduce type spec keys, which is just an array of strings. Make lit string. So we have type def, struct, union, enum, and flag enum. Alright, so if I match any of those things, then we are off. We have found something we can start on. So, oh, I get it. I get it. Yeah, okay. So we basically have here, we're doing type def. Case 1 or 2, we're doing struct union stuff. Case 3, we're doing an enum. Case 4, we're doing a flag enum. Okay. So now we've got that all worked out. Let's just do these one at a time, I guess, since I can't really do them all at once as a single human being anyway. Maybe I should go do the water first, though. Yeah, I'll do that. Be right back. Okay. That settles that problem. So let's try to parse this type def. So the token we're on is the type def. The doc string is the previous one. Let's get that one first. So, and it never pays to skip the brackets. Never. Whoops. Damn it. Now you see I can't use any of my clever tricks. There we go. Okay, so the first thing I want to do is go backwards and get that doc string. So if I is greater than 0, prev token equals tokens plus I minus 1. If prev token type does not equal CPP token comment, or if it does equal CPP token comment, I should say, then go ahead and set the doc string equal to whatever you get when you make the string, file data plus damn, mouse is in the way again. What's going on over here? Alright, so file data plus prev token start, prev token size, and then what I want to have is like doc string equals trim block comment doc string, because I've already got this implemented later on. So let me go find where I've implemented this. Oops, not that. There it is. Perfect. Check and fix docs. That's what it's called. If check and fix docs, doc string, right? So that what it'll do is make sure that it's at least large enough, and then adjust it to eliminate that. Perfect. So I do that, and then I'm going to store that, right? So now I can go ahead and say, all right, this goes into the first type def, and well, you know what I should really do is before I do any of this, I should just count all of those. Okay, so what I want to do is, this is all good important stuff. I'll keep it sitting around down here. Up here I want to count how many of these I see, and we'll just assume that that's, you know, the maximum number of them that I'll need. So type def count equals 0. 1, 2, 3, 4. Struct count equals 0. Flag count equals 0. Enum count equals 0. Then what I'll do is I'll take u plus u blah blah plus u struct count enum count flag count. Alright, now having gotten all of those, what I can do is set all of the sets to have the right thing. So type def set, we can do memory size equals, mouse is in the way again, size of string times 3 times the type def count, right? And yeah, that's all I should need. So then I'll do type def set dot type equals string malloc memory size type def. Oh, I could do this. Okay, so forget that. Push array onto my partition. Push the string type def count times. This will all be if type def count is greater than 0, because I'm not sure what happens if it's not. So there's type, name, and docstring. And this is sort of the reason that I wanted to switch over to using the array thing in the first place. It just makes my life easier for doing these kinds of things. So type def count, struct count, struct set dot structs equals push away struct members, push away. Yeah, that's what I meant to say. Push away. If enum member count is greater than 0, enum set enum set there it is. Enum set name equals push away string enum count. Type, why does it say types? Type equals push away enum count. Enum member. There's no handmade here today, so I might go as long as I need to. And finally, docstring. Enum count. Alright. So that gives us yeah, okay, great. Flag count greater than 0. We don't need types on flags, but we still get names, first members, and docstrings. We don't use enum counts, we use flag counts. And we don't use enum sets, we use flag sets, which just sort of happened magically by accident just now. Okay, so that should allocate all of the base level set structs to have enough memory. And then what I want to do is set all of these to have like an index version. So Alright. So now, here I am, doing what I was doing before, in the middle of this loop, and I just checked and fixed the docs for the type def. Then what I want to do is I want to say, that's nice. What's the next thing I need to do? I need to figure out the name of the type and the name of the identifier, the name. So what I want to do is parse until I see a semicolon identifier, right? So what I'll do is say something like for I less than count plus plus I plus plus token, if token type equals CVP token semicolon, then we can break. If I is still less than count when we get to the end, then what I want to do is say, alright, shit. Alright, there we go. Back to normal. So we got the semicolon, then what we want to do is back up one, or back up until we find an identifier. So for I greater than start I minus minus I minus minus no, 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 don't, no, 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 no. For j equals I, j greater than start I minus minus j minus minus token j. And so what that means we need CPP token j to equal token. The mouse is in the way. Up here, I want to store int start I and start token. Let's see. Um, Miblo, about the multiple increment thing. Let me tell you a little bit about this, because this is kind of a weird little feature of C that's kind of odd and fun. So yeah, you can see right here I am doing a double decrement on this, and you know, if you look up, where did I have? Oh, right here I'm doing a double increment, and I believe up in my original for loop, which is not necessarily in view right now because I'm oh yeah, way up here. Ah, shit. Figured that would happen. Double increment again. So that's something I use a lot. And what's actually happening there is it's not like a special rule with for loops being able to double increment. What's happening there is that the comma operator is happening. So it's like, you know, you can do things like plus plus x minus minus y and as two separate things. Well, if you want in C, what this right here is an expression, and this right here is an expression, and when you put the semicolon on it, it becomes a statement. And a statement is, if you don't put the semicolon on it, you don't have a statement, and that's when you get sort of a parse error that's like, oh, I'm only expecting statements. You got like some sort of invalid expression here where we go like plus plus x minus minus y. That doesn't mean anything, right? That expression doesn't mean anything, which is basically what it sees. But there is a way to just take two arbitrary expressions and stick them next to each other without turning either of them into a statement. And that's the comma, right? If you put a comma between them, that actually tells it, hey, this is an expression, this is an expression. Without the semicolon, it's one big expression that doesn't end in a semicolon. With the semicolon, that's a statement now made out of one big expression. And the comma doesn't really do anything except for to say these two expressions, I want them to be one expression. Which means anything that takes an expression, like the right-hand portion or the central. Actually, I don't think this does because it needs a true or false value, but this right here, which takes an expression, you can put a comma there to do any number of expressions you want. One other note, in a function call, that's not what the comma is doing. The comma stops working inside of the function call, and if you want to use the comma, then you have to put like parentheses around stuff so that it knows that the comma inside the second layer of parentheses is not for our parameter. I forget whether it's the first or the second operator of the comma that gets returned from the expression. Not sure about that. Anyway, the mouse is in the way. So I'm parsing backwards now, looking for an identifier. So there we go, I found an identifier. Damn, how does that happen every time? I don't understand, that shouldn't happen. Boop. Now, oop, that's not where I want to be. There we go, I've got an identifier. And now I want to store that as the name of the type def. So, string name equals make string file data plus token j start token j size. And I've also got now the type of this type def, because I can make that by just going file data plus, let's see, start token was the token where we found, yeah, start token was the type def token. So what I can do is take start token start plus start token size, and then go all the way until token j start minus this amount. So it's something like int start int type start equals this, int type end equals this, start end minus type start, and then we can just skip chop the white space on the type, and as long as I don't put any comments in between the type def and the semicolon, that should work. Alright, so now I've got a name, a type, and a docstring. That is all I need to create a type def set entry. That's correct. Whoops, can we stay up there? Type def set. Thank you. So type def set dot type def index equals type, and we're going to have name and docstring as well. Uh-oh. Name and docstring. It's still fucked up. Type def name and docstring. Oh. Name and docstring. There we go. And then we can increment the type def index by 1. And then the loop out there will be at the, let's see, we incremented the real one all the way to the semicolon, so the next thing it reads will be whatever's after the semicolon, right? Yeah, so it'll read that, and then it'll continue from here. The next thing it sees will be something else. Okay, cool. So that is not that bad. I'm going to end up with 4 of these. And they all start with the same exact docstring rule, so I'm going to pull that out into a function first. So that's something like, if I switch to metagen again, and I come all the way up here, this is something like it needs to return true or false, get type docstring, and so let's see, yeah, so string docstring will hang out right here. Whoa, okay, that's bust. It's using the cursor from the other view for that command, which is a problem. Definitely a bug. I'm going to Yeah, I'm gonna deal with that tomorrow, if not here on stream when I'm done with all this. I think I know what that is. Alright, so anyway, we do all this, and blah blah blah. Yeah, so here we are. Okay, check and fix docs. Okay, everything else we'll be able to work out. So get type doc string goes there. And let's see, we don't have one to match you. We don't have one to match you. So there we go. You guys come over here. There we go. Yes, so you're going to need a few things. Int I. You go back down to get type doc string. Okay, int I can give you. CPP tokens. I can give you string pointer doc string. I can give you. File. CPP file I can give you. Yeah, so this should be like type file. Oops. Oops. Type file, type code. String does not have a. My bad. Types tokens. String. Set type equals push array. Cannot convert argument. Part. I see. Partition. Part equals part. Right, and you need the type file, the tokens, the index, and the doc string. Let's see, type file, type file. Oh, hold on a minute. That's odd. I'm gonna stop the stream right now and maybe be back in a minute.